painted cubes problem, where kids can see it, touch it, build it, all that stuff, gives us n cubed 8. This guy,
12 n minus 1.
do I need more? So what is this in terms of s?
2.
It's 12 times n minus 1. Right? And then these guys?
N minus 2.
Oh, the 2 in each case. So it's
Yeah.
n minus 2 squared times
6.
You got it. Times 6. How interesting. So in other words, this is backwards, right? It is. And then this guy over here is n minus 2 cubed. Play with me. N minus 2 cubed, multiply it out. Plus 6 times n minus 2 squared, multiply it out. Plus 12 times n minus cubed. Plus 8. What do you think it's all going to end up being?
End of the third.
You got it. Wonderful. All I know is that I have thrown in 2 bonus problems for you to play with if you so feel like it, okay? Number 1, there it is. When all is said and done, the bottom line is you study for an hour, you're going to get a 60. You study for 2 hours, you're going to get a 74. You study for 7 hours, and the good news is you are going to get an 84 on the test. Every bone in your body should sit there and want to now sit there and say, all right, that's a 50, that's a 100, so there's 60. So if I study 1 hour, I'm going to get a 60. If I study 2 hours, I'm going to get up to 74. If I study 3 hours, I'm going to get an 84. I'll be damned. It just looks like this. This is the number of hours study. This is my grade, right? Assume it's a quadratic, go and find it. How do I find that this is a quadratic? Ladies and gentlemen, what we haven't done today is y equal ax squared plus bx plus c. How many variables? 1, 2, 3. I plug in 1 and 60, right? And I have the ability to say a, when x is 1, plus b plus c equals 60. So far, so good? When a is 2, 4a plus 2b plus c equals 74. 3 variables, 3 equations, 3 unknowns, 7. 49a plus 7b plus c, 84. When you solve those 3 things, you get A, B, and C, and you then were able to tell me the grade based on the number of hours. I have a question for you. What does this mean that at 7 you are back down to 0? I didn't mean 7. I meant 12. You all said it. It means that you're a moron. You stay up all night studying 12 hours and you fall asleep during the quiz. You're on the test. Exactly right. You max out here at about 6 hours, I think, in some way, and all that stuff. You know what's so cool about this? You study all you want, you still can't get 100. That's why I really like this. So anyway, it's another problem that I give to you to go play with. I know there are people in the room that are ready, that would love to try that with your pre-calculus kids, and then go see how it works in other kinds of places. And then I end with the Diamondbacks. You know, I mean, they're not going to go very far this year, but that's, you know, my Yankees will take care of that. Oh!
It's about the Red Sox.
Oh, the Red Sox, please. Wait. Right? You know that the only thing that really matters when all is said and done is that I have the question of when I hit it at 55 degrees at 90 miles an hour, is it going to get over the wall that's 10 feet high out there in center field? In other words, I have this situation where I start 5 feet up, and this ball takes this amazing path, and the question is, will it or will it not hit a wall 10 feet high, 420 feet away? Now, if it isn't clear to you that the home plate is 0-0, 0-5 is where the ball is hit. And then when all is said and done, mathematics is about the fact that you hit it this way, but it has a, I mean, you hit it this way, but it has a horizontal and a vertical component. And that those are defined on the basis of the angle and the initial velocity. Once I decide the angle, my calculator tells me what the sine and cosine are. And what I love about this is, on a graphics calculator, when I play this whole thing out, and I watch this 55 degrees, which I know is this, and I know what this is because I can put this in, and I graph it out, and all of a sudden, and it falls just below the 420/10. In fact, the point is 429.1. Oh! And when I then cue it up for 45 degrees, which you all know is the perfect angle for maximizing the distance, right? And the kids watch, and I get it to here, and I turn my calculator off. And oh, they start screaming at me. And I turn it back on, and I have never had a class of kids do anything other than cheer when it clears the wall by about 1.5 feet. Ladies and gentlemen, today really was cool. Today was cool because we started with the celebration of the cool things you're doing and the fact that it comes down to kids. Today was cool because you saw me muddle. You saw me totally in control, and you saw me having no clue what was going on and trying to make sense of it. And I was pissed that no one in this room rescued me from that pit. But that's what happens. But I think that you know that the most important thing that happened today is I gave you permission to do more of the problems in the context, and permission to recognize that you're going to raise those Ames scores not by factoring and symbol manipulation, but by building an understanding of a function and building it on the foundation of linear, and then seeing how, when I go beyond linear, I have these problems that allow me to do linear to quadratic, and then linear to quadratic to cubic. And you've got an evaluation form to fill out. I'm back in November. Once again, I leave here feeling very positive about this session and about this interaction. Thanks, guys.
If on your way out, please give me your evaluation form. That would be lovely. If you would please grab a slice of pizza for the car. There's tons of leftover pizza, and I don't want any of it still here. So please, if you grab a bottle of water.